Welcome back, everyone. Good afternoon, and thank you for joining this afternoon session titled Broadening Participation of Students of Color in Data Science, Centering Creativity and Community. My name is Tasha Austin, and I'm a principal at Deloitte, and I'm also the director of our Artificial Intelligence Institute for Government, as well as the executive champion for Deloitte's strategic engagement with our HBCU community. I will tell you this is so important to me, today's discussion, because I am a proud graduate of two HBCUs, North Carolina Central University and Howard University, with an advanced degree in mathematics as well as an MBA. And so personally, I'm excited to be here, but on behalf of Deloitte's Artificial Intelligence Institute, we are certainly excited to sponsor this event in partnership with the University of Virginia's School of Data Science. And talking about our Artificial Intelligence Institute, I'd like to highlight a couple of things because there certainly are some synergies between what we are focused on in the Institute, as well as what UVA is doing today. And so the Artificial Intelligence Institute for Government was established to advance applied AI in the public sector by building a cross-sector community for research, shared expertise, mentoring and growing talent of the future, with a particular focus on diversity, equity, and inclusion. And our Artificial Intelligence Institute focuses on 4 outcomes. More specifically, these priorities are connected to our mission. They're namely trustworthy AI, they are AI at scale. Another area we're focused on is AI and its role in national competitiveness and AI's role in equity. And so Deloitte continues to be thankful for our continued partnership with UVA School of Data Science, because there's a number of opportunities that UVA has embarked on that certainly aligns to our own priorities. Notably, I'd want to highlight a few things that we've done with UVA to date. We sponsored the HBCU Bridge, Summer Bridge program, which was a program that brings undergraduate students from partnering HBCUs to UVA's campus for collaborative AI and equity research. And I will tell you that I was so impressed by the work that the students did. They did a lot of research in health equity. We know that's important because of where we are today with the COVID era. And so the outcomes, the research that they stumbled across, the discoveries that they made during this program were just really impressive. And it truly shows and amplifies the need for our future leaders, our students, to continue to develop in this space so that they can help us solve a lot of our real world challenges. And so we were very honored to be sponsors of that program, and we look forward to sponsoring UVA with that program next year. We also sponsored the Women in Data Science Forum. We know this is important. We want to see more women in this field. And so we're very happy to be a part of that collaboration with UVA. And today we're now serving as the sponsoring organization on this important discussion. So in thinking about what the panel is going to speak on today, I want to highlight 3 things. First, today's discussion brings the priorities of AI's role in equity to the forefront, which is something I'm very passionate about, and I'm sure many of you are. And our conversation will allow for us to explore different perspectives on how we can help foster opportunities for students of color to have exciting careers in data science. And the key to making this happen is accessibility and opportunity for all students to ask and answer big and bold data questions, and to help us solve those questions, help identify those answers. There's another area that we're focused on, and that is the need to expand access to data science careers. And that continues to be the topic of much discussion across industry, including Deloitte. We're continuously thinking about that topic day in and day out. And it's also a topic of discussion in higher education. And so the panel is going to highlight programs and efforts that they're focused on to broaden participation of students of color in data science, in computing, machine learning, as well as in artificial intelligence. And what distinguishes these programs and efforts is that they move beyond the usual practices to center the students' humanity, creativity, social consciousness, and community spirit to engage and empower them to tackle economic and social issues with data. And so you're going to hear a lot about that today in our discussion. And so I first want to just say we're so fortunate to be joined by an outstanding and amazing panel of leaders hurled from diverse backgrounds, organizations, and research areas that are on the front lines of broadening participation of students of colors in data science. And so before I pass it over to each of the panelists, I'd like to have them introduce themselves, but I first want to emphasize the impact of what these amazing leaders have been focused on. And they continue to focus in these areas, and they're all about helping develop the next generation of talent in data science, particularly for students of color. And so today you're going to hear about the impact that they have made at the university level. They have been focused on instructing students on hard skills and inspiring problem solving for big questions in data science. They've been focused on inspiring and reimagining the applications of data science and artificial intelligence. And they've also been focused on being an active mentor and role model for students of color in this evolving world of data science and AI. And so the importance and the impact of the hard work that all of these amazing leaders is focused on needs to continue to be amplified. And I'm so fortunate today to be able to help open the remarks for this session and have an opportunity to amplify and tee up some of what you're going to hear from them today. I personally want to thank all of our amazing leaders, our panelists today, for their dedication to the creation of accessible data science, and they're doing a lot of work in some very innovative ways. And so as you'll see from our panelists' diverse and impactful backgrounds, today's discussion is even going to help us, think through how we push forward to create opportunities for youth of color in data science. And I want to express my heartfelt thanks to Claudia, to Wendell, and just to UVA overall for creating this forum to help have this important discussion. Look, at the end of the day, Deloitte stands with this community, and we're continuously committed to supporting opportunities to drive a diverse and equitable data science workforce. And with that, it is my pleasure to turn it over to Dr. Natrice Gaskins, who serves as the Assistant Director of the STEAM Learning Lab at Lesley University. And she does a whole lot more, and you're going to hear about it. And so at this point, I want to turn it over to Dr. Natrice Gaskins to take it away.
Great. Thank you, Tasha. I want to talk about artificial intelligence from the standpoint of an artist, and share with you some developments in technology that led me to exhibit my my art at the Smithsonian, which opens tomorrow in the Futures exhibition. And so I'm going to share some slides. I'm going to skip around. It's a bigger presentation, but it has the slides that I want to share. So the type of AI that I use to make art is from deep learning, which is a subset of AI, of machine learning in AI that uses multiple layers in a network topology. So there's an input layer, or source or content layer. And then there's these hidden layers, these neurons that move and then kind of collapse together into an output layer. And so in 2015, Alexander Morvancev, he decided, he realized that AI, instead of it being something we tell it to do and then it does, he was wondering if AI could actually think a little bit on its own or learn on its own. And so he used this image of a cat and a dog as a reference for deep learning to create what he called a nightmare beast. And so this was the beginning of a technology that I now use. And this is the result that he called this application result a deep dream, and really thought, what happens if the AI can dream? What happens if machines can dream? What's possible? And so this was one of the first outputs that came out of the deep learning experiments of Morvancev. And there have been others. He was part of a computer vision research team at Google who taught computers how to understand digital pictures and sound. And so they were looking at convolutional neural networks, or ConvNets, or CNNs, that are able to recognize objects and spot patterns in data. And so to train a ConvNet, you feed it millions of images from a database. And in this case, ImageNet is 14 million URLs of images. And then what it does is it sort of takes different features. First, the first layer is the image, and then it picks out more and more details as it goes along. And then the last layer assembles all of the images into a final image that you can, let me put this in present mode so it's easier to see. And so you can see here, this is kind of how it works, the feature extraction, and then it flattens it out to create that. So I'm going to skip, here's some examples of that. This is Deep Dream Generator. So you can see there's a town, there's Van Gogh's Starry Night, and then it takes it and certain features of it get applied to the original source image to create kind of a starry scene using something called image style transfer based on the neural network in Deep Dream. So humans and AI collaborate in this way and can create digital art that uses the CovNet idea and uses deep learning. And this was a real introduction for me because I was teaching AP computer science principles to students in a high school for the visual and performing arts. And I wanted to make sure they didn't drop the class. So it was important that art be a focus of the AP class. And so, and nobody dropped the class. So I had 16 students, most of them were girls, and most of them were African-American and Latino. And so this was one of the applications or tools for them to get familiar with AI and understand how algorithms work by using Deep Dream Generator. And so this is an example of one of my works. There's the content. And in this case, the style is antique or vintage lace, and then the output. Another example. And at some point I began compositing output. So there's a source image, and then through the hidden layers, the two different outputs, two different styles, and then combined is the final. And this is Octavia Butler. And so this image, which is actually in the Smithsonian on the far right, it started with my portrait, and then I did multiple styles using kind of an Afrofuturistic lens, thinking about Afrofuturism and also thinking about the Smithsonian, using things like museum tiles, sacred geometry and fantasy type of images, and also another output image as the style. And so you can see that I'm going through several iterations of the machine learning process to get the composite. And now that composite's been printed out and is a totem in the Smithsonian exhibition, along with 10 other images. And then it's in a space that looks almost just like this. This is the mock-up, and I've actually been in the space in the last couple of days, and it looks just like this, give or take a few chairs. So 11 images has been woven of these AI images that I've created have been woven into this space at the Smithsonian. And each image has some relationship to the artifact that it's next to. So Floyd McKissick, who is known for his conception of Soul City. I used city plans and blueprints and things as the styles to create his portrait. For Alexander Graham Bell, I used wire, the actual drawing of the patent for the telephone, and cables to recreate his portrait. Helen Keller was Braille, the actual Braille that's produced by the Braille machine her image is next to. I also used watercolor in terms of sepia color, and also vintage lace. And so each one of these featured futurists in the show, all of these were created using the image style transfer process. And that's what and these are some examples. The Helen Keller was really interesting. Margaret Hamilton is using binary code related types of images. And for the Dr. Corbett and the one with the vaccine researchers, it was great seeing that the actual researcher was standing next to this portrait last night to see how closely it does look like him. And it was great that was shared on social media. And the curators did a great job of creating actual space around these images. They're very much embedded into the show. This is another example of my work. Here I'm doing Deep Dream, but I'm also using processing programming language what's called a leap motion controller, which I'm drawing with my movement of my hands. It's sort of a sensor, so you can see it on the far left. And this is the array that I'm using is mimicking the fringe in Aretha Franklin's jacket or coat. So I'm using other processes, not just Deep Dream, and creating these portraits. Lastly, we use Trinidad Carnival as a vehicle for exploration of AI art and design. So we created the Carnival-AI app, the Carnival AI app, to further amplify Black joy and from Trinidad Carnival and across the Caribbean. So there's an actual app that has multiple tools you can use, and it's using in the same deep learning umbrella something called pose estimation or PoseNet, which is allowing to track position of the body. And then you can use that tracking data to do different things like create paintings or even a dancing partner. So that we did more recently, it launched in September. This is using a generative adversarial network, or GAN, to take all the costumes, many costumes from Carnival, to create these kind of futuristic costumes. And this is Vernell Noel, my partner. And this is the posing that I talked about. And then this is the actual app where you can come in and dance with shapes. There's some examples there, and then paint with the movement of the body. And this is using AI as well. So as it relates to techno-vernacular creativity, what's really important about my book, and also what it tries to do, is it looks at creative practices from communities that are usually overlooked, and from artists and practitioners who are connected to their cultures, and how they engage science and technology in ways that may be different from what's in mainstream discourse around technology. And so from Trinidad Carnival to, music, musicians, even the idea of computer graphics and using effects that are based on darker skin tones. All of these things have a role in what I call techno-vernacular creativity and innovation. And this is just one personal example, but there are many others that I talk about in the book. So I just wanted to connect that really quickly before I stop talking. I think that's it for sharing. Thank you.
And so we will, you can put your questions below the live stream. You can click and enter your questions there for Dr. Gaskins. Next, I would like to introduce myself. My name is Tiffany Oliver, and I serve as an associate professor and chair of the Department of Biology at Spelman College. And I am here working today with Jamaica Williamson, associate director of budgets and contracts at Spelman College. And today we are here to tell you about the incorporation of contemplative practices in Spelman's data science summer research program. Next slide. And so if we go back to March of 2020, right as the world went into quarantine, from the students' perspective, they faced many problems. Most of them lost their jobs, which represents lost income. They also lost their summer internships, which means that they're losing experience. Most importantly, there was a lot of stress due to racial tensions. In March of 2020, right as we went into quarantine, Breonna Taylor, African-American woman, and EMT was killed when the Louisville police raided her apartment as she slept. And George Floyd was killed just 2 months later in May of 2020 when an officer kneeled on his neck for a minimum of 8 minutes and 46 seconds. As faculty at Spelman, a historically Black women's college, I could see the impact of these racial tensions on our students, right? This is a women's college, HBCU, where over 60% of students are Pell eligible, and 90%, a minimum of 90%, identifies African American. I had many one-on-one conversations with our students, tears from loss that they had experienced, family members, opportunities, and also they were participating in protests that were related to the killing of Breonna Taylor. And so our students, they needed respite. And so after a brief conversation with the president of Spelman College, President Mary Campbell Schmidt, who expressed her financial support, Spelman's inaugural data science summer research program was born. So why data science? 11.5 million data science jobs will be created by 2026, and women and people of color are sorely underrepresented in the field of data science. Another reason why focusing on data science at this time when we went into quarantine was important is because data science-based research can be conducted from home, which was ideal because everyone had to stay at home. Data science is also relevant to all disciplines and all majors, and so all students, in essence, are eligible to participate. And so as it pertains to the structure of the program, students engaged in coding. So they learned how to code in Python. They learned data manipulation, data representation, visualization, basic statistics, and cloud computing. This was a 6-week program. They also engaged in professional development. They had weekly conversation with data science professionals from companies like Delta, Dell, the Southern Company, Facebook, and more. They participated in workshops on CV development and worked on their LinkedIn profile. They also engaged in mentored research with the Spelman College faculty member. But this research project was a data science-based project. So they were using the skills that they were learning in class and applying that to real-world data as they worked with faculty. And finally, the last part of our program was contemplative practices. So students engaged in weekly workshops on contemplative practices. These are activities like yoga, stating affirmations and intentions, coloring to connect, meditation, journaling, and creating visualizations. And so why implement contemplative practices into a summer research program? Many students expect computer programming to be difficult and to come with the notion that they will have to struggle. And these beliefs can affect their motivation. There was also stress from the racial tension of the time. And so contemplative practices have been shown to alleviate psychosocial stress, as well as stress that's associated with learning new things. And so that's why we incorporated them within our program. And so I will turn it over to Jamaica Williamson.
In our approach, students that participated were stratified by major. Based on their major, students were classified as being either in the arts, social sciences, natural sciences, and math, or humanities. Over the last 2 years, we have had 73 students in the program. And as you can see, students were from all classifications and from all disciplines. Since students from different disciplines participated, we wanted to see if there was a difference in the average GPA by discipline. We did not see a significant difference in the average GPA by discipline. Next, we measured students' interest in data science as they progressed through the 6-week program. We surveyed their interest at the middle and end of the program by asking them to rank their interest on a scale from 0 to 5. In the natural sciences and math, the interest stayed about the same, but their interest was high initially. Social science interest increased the most, and it was also the lowest to begin with. We next surveyed students on their confidence in applying data science concepts to solve real-world problems. Among students in humanities and the social sciences, as students progressed through the program, we saw a significant increase in their confidence. For students in the arts and natural sciences and math, there was an increase in confidence as well, but the increases were not significant. By the end of the program, students were more readily able to identify data science careers in their discipline. However, the arts and the humanities had a much lower initial ability to identify these careers at the beginning of the program. We then asked students about the impact of the research they engaged in on their interest in a data science career. Social science students' interest increased significantly between the middle and end of the program. That doesn't mean that engaging in research doesn't help those in the other disciplines. It just means that their initial interest was high and remained high throughout the program. The hallmark of our data science summer research program is the incorporation of contemplative practices, as we spoke about earlier. The incorporation of contemplative practices into the data science program is actually quite novel. As early as the middle of the program, students' understanding of contemplative practices increased significantly. Students' incorporation of contemplative practices in their daily life also increased by the middle of the program. The students enjoyed all of the contemplative workshops, but enjoyed intentions and affirmations the most. What we learned using our unique population of Black women is that the program increased students' ability to identify data science careers across all disciplines. What really stood out to us is the trend we see with social science students. Over time, the students had an increased interest in data science, their confidence in solving real-world problems increased, their ability to identify data science careers increased, and the impact of engaging in data science research increased their interest in data science careers. In terms of the contemplative practices portion of the program, students' interest in use of these practices increased as soon as the middle of the program. We currently have a grant under review with the National Science Foundation to examine the impact of contemplative practices on students' learning gains within the context of the data science program. In closing, I'd like to acknowledge the Southern Company, the Office of the President at Spelman College, and all the student and faculty participants. I will now turn it over to Dr. Uma.
Thank you, Tamika. I'm Uma, and I'm a professor of computer science at NC Central University, which is a HBCU and a liberal arts university. Our project is on data science for social justice as a means to open doors to STEM. Our team includes Alade Tokuta from NC Central University and Rebecca Lowe and Adrian Smith from Science Consulting. And this is an NSF-funded project. It is ongoing. So our rationale for using social justice was that McGee and Bentley had identified that minorities were more motivated by what they refer to as the equity ethic than getting a big paycheck. And that when they look for STEM careers, they are looking for careers where they could integrate their STEM expertise to address social justice and equity matters in their profession. Second, the team at Northeastern Scientific Testing Center had arranged a workshop, and they had invited people from across the academic spectrum, from undergraduates all the way through faculty and minority candidates, and asked them what needs to be done to diversify the STEM workforce. And during that retreat, they had come up with about 8 actionable items. And the first one of that was to say we need to include social justice component in STEM training. And data science clearly lends itself to incorporating real world problems. And that is one way to attract and retain students in STEM fields. So given all this, we decided to use data science as the vehicle and incorporate social justice into it to attract more minority students into STEM. So we chose a freshman seminar course where students from across campus are required to take. And in that course, students were required to work on a social justice project. They had to analyze the issue and present what is being done and possibly solutions if they come up with one. So we thought that would be an ideal course to incorporate our project in. And so prior to our getting involved with that course, students would choose a social justice topic. So one year the student had chosen on police brutality, and they would look for sources on the web or articles, published articles, and locate these figures like Black people were 24% of people killed by cops, and they would put that in their report. So what we did was we provided them with the raw data set that Washington Post had compiled of victims killed by police. And so now the students can create this graph on their own and see that, yes, 24% of Blacks are victims of police killings. And when one interesting thing that happened was when one student was working on this, he saw that whites were 46%. And his immediate reaction was, no, the data is wrong, or the data is, something is wrong with the data. This is not correct. So that was a good opportunity for us to introduce critical thinking as well. And we had to have discussions with him to start thinking about the representation of the Black and white in the general population. And so once he started thinking along those lines, he realized that, okay, even though magnitude wise, if whites are 46%, it's still Blacks are disproportionately affected by police brutality. So this also gave us an opportunity for them to realize the full picture rather than just see that number 24% written in an article, and also analyze what is the main issue in the police brutality case. So incorporating data science into with a social justice component into the freshman seminar, or even in, say, a statistics course or any other course a person can want to, does come with challenges. For the instructors, the challenges are, of course, we need access to data sets, and the data sets may not be in the format we need. So the instructors will need to have the ability as well as the time to clean it, to provide it to the students. And if faculty from across campus in non-STEM fields are also utilizing this, they also need to be skilled in the necessary tools like CodeApp or GitHub that is required to clean the data sets, as well as have the ability to involve both STEM students and non-STEM students in their analysis of such projects. For the students, the challenges are, of course, that they do need to pick up programming, because I said this is across campus. All students take this course. So non-STEM students will also need to pick up programming concepts, and they also need to know basic statistics. It depends on how much of statistics they have done in high school prior to that. And they also need to have the required logical and critical thinking to analyze the problem once they do have the data and generate some graphs of it. So to help alleviate that, what we did through this project is we identified the social justice issues, and we sourced data on these issues. And all of the data we have sourced are publicly available data. And then we do the cleaning and the transformation and provide a data dictionary if one was not available. And as a result, we were able to generate curated data sets, and to also help students, okay, once they have the data set, to give them an idea of how to proceed analyzing it. We do also post research questions and guiding questions on each data set. And we provided tutorials and resources on the tools that they would use. So the first year we did it, we provided R and we provided sample code in R. But still, since majority of our students don't take programming courses in high school, it was a steep learning curve. So the second year we switched to a no-code tool such as CodeApp, and that was better. And our future plan is to create lesson plans to go with these data sets, so that faculty from across the country or even across the globe, and not only in college level, but also high school level, could take these data sets and assign it to their students. It can be in a criminal justice course. It can be in a communications course. It can be in any discipline. So we make all of this available in the project website. And currently we have curated data sets on a variety of topics, including police killings, domestic violence, gun violence, environmental pollution, cost of college education, as well as child abuse. And we are working on LGBTQ issues and mental health issues, immigration, etc. And almost all of these topics, barring COVID-19, came from the students. They asked for data on these topics. And in fact, they have asked for data on even additional topics like lynching. And I had to tell them that they wanted modern day lynching. And at that point, I was not, and I still am not aware of a source of data for that. So if anyone has, please point me in the right direction. So I wanted to briefly demo how quickly students can start visualizing the data set. So they will go to the website we provide with curated data sets. So they will go to the projects page, and all the curated data sets are available. So if they choose the fatal police shootings, and let's choose that data set. So So they can download that data set, and then they can switch to CodeApp. Let me move this off my screen. They can switch to CodeApp. And CodeApp is, again, a free web tool to help with data analysis, and it is accessible even for middle school students. They launch CodeApp, and they will have to import the data they just downloaded. And it does take a few seconds. So they have now imported the data. So now to create the graph, they click on the graph icon, and on the x-axis, if they want the race, they can select which variable they want on the x-axis. So if they select race, it now creates the bar chart where it shows the distribution of victims by race. And they can make this proper bar chart. And if we want to get an idea of the percentage of each category, they can have the percentage displayed. And we can see that, okay, blacks are now 24%, whites are 46%. And of course, now if they want to say, okay, I don't want A, B, I want the name of the race listed in full, what they would have to do is they can close the graph and they pull out the race. Let me extend this a little. They pull out the race to the higher level table, and now they can just go and change this to Asian, white, and it is as simple as that, renaming the values, Hispanic, black. And now let me, in the interest of time, let me just do the graph now. Oh, I forgot. Let me move the, let me move it back in. Okay, and now you can see that the labels on the x-axis get the full words for the races. So it is very simple for even a middle school student to visualize data, begin to visualize data this way. And of course, when students are more interested, they can always further explore using R or other tools. There are additional no-code as well as low-code tools, so we can introduce them. Currently, we do provide tutorials for CodeApp and R for students to use those two tools. So I will stop my presentation here and pass it on to Dr. Tedega.
Thank you so much. I mean, I'm just amazed at all the beautiful things that are happening across the U.S. Around broadening participation in data science. My name is Sharon Tedega. I'm at the University of California, Santa Barbara. I am currently Associate Vice Chancellor for Diversity, Equity, and Inclusion, also the Director for the Center for Black Studies Research, and I'm a professor in the Department of Black Studies and Computer Science. So I wear a lot of hats. I have a lot of things that are going on. Yeah, and it's just exciting to see all these amazing things. So today what I'm going to talk about is our SEEDS program. Let me get my screen up so I can actually share this. Okay. SEEDS is basically Students Enrichment and Engagement in Data Science. This program was conceptualized through many conversations that I had with students on this campus, mostly African-American students, having the conversations about we don't feel like, we're being heard. And I don't like to use the word belonging because I don't believe in it, because I don't think anyone wants to belong to a racist institution. So I'll just say they just don't feel like their particular way of knowing was being heard. And I think we have to start understanding what are the needs of the students. And that's what this program is really based on, getting together with students with diverse epistemologies, diverse ways of thinking, of knowing. And I felt like that was core to this program. And I thought about, okay, how can we leverage diverse epistemologies using the student voices And I wanted to focus on students across campus, regardless of their major. So we have right now in the program 31 majors. We had 242 applications for this program. And I call it a program because it's not formalized, it's not required, it's something that they're choosing to do. And I was just surprised, I was worried at first, how are we going to get all these students? And we actually have more than what we can handle. So if one decides they can't handle it, then we bring in another student. And it requires them to sign a contract, say, we really want to be in this program. And that's how we keep them in it. And we have this living and learning community that we're building around this, around data science. I was thinking about it in a way, it's a convergence through multiple disciplines. It's a living and learning and social development. It's development of common interest. It also increased diverse knowledges because they're working with each other and they're connecting to real life issues. And it's based on participatory design. A lot of the stuff is emerging from them. We're giving them the skills that they need, but everything is coming from their ideas. And how does that happen? It happens through this living and learning community, and I say it's pedagogy and andragogy because students are different ages. Not everybody is someone that's just 19 or 20. We have students that have an age range from 18, from freshmen to sophomores. I'm only working with undergraduates because I would like to work with them for several years, and many of their ages, again, are different. So what do? These are our 4 pillars. We bring in experts that come in every other week across different disciplines. So far, because it just started this fall, we brought in someone that talked about data, Alan Craig from NCSA. Data's everywhere, and people need to understand that there's all types of data. Data is a point in space and time, and we have to remember that anything is data, and that's what he talked about. Then we had another speaker that came in and talked about how they're using virtual reality and gathering data around emotions and in the medical field. And a third one, we talked about the social dilemma. We had Joe Walter, who talked about fake news and the social dilemma. And more recently, we had one of my postdocs, she actually presented on W.B. Du Bois and his data. So a lot of diversity and representations of data. The students also have to develop their skills because I really wanted it to be when students leave this program, what would they leave with? They're going to leave with an understanding that there are different people in the world and we all don't think the same. They're also going to leave with skills. So they have Bash, Git, R, Python. They've been looking at some of the census data. So they actually engage in these workshops with data carpentry. And then I felt like it's really important to have these open discussions with them so that every other week, because these things are bi-weekly, except for the data carpentry, that's based upon when they're available and they all get the same kind of skill training at the same time, all 50 of them. So then the diverse epistemologies, of course, that's how do they come to know? The ontologies, how are they in the world? And then what is value? Because often we value, or we're forced to value, a very white male system. Because remember, higher education was developed for elite white males. And many of the way things are done, they're still done that way. So why can't we have it where all of our epistemologies are welcome and what we value is welcome? So, and how we are in the world. So if I want to show up and speak Ebonics, it's going to be okay. And I'm going to be okay with it. I'm going to be safe. And that's how I see this space, is that students should be able to come into a space and be themselves, talk about what's important to them based on how they know things, how they are, and what they value. And then the fourth component is the research component. Each of these students are placed with a mentor where they're doing research, and it ranges. It's a lot of different areas. And the students were placed there based upon where they wanted to be, also where the mentor felt like it would be important that they could really build their knowledge in these areas. So those are the 4 pillars in the living and learning community, and that's the foundation of this program. We have a group within SEEDS called BRAIN. It's called the Black Researchers Advancing Intelligence and Neural Computation. And let me make something very clear. The 50 students that are in the program is diverse. It's indigenous, as well as Black, as well as Hispanics or Latinx. However you want to, talk about that. That's a term that I have problems with, but I won't go into that right now. And then we also have first generation within the SEEDS program. But the BRAIN program is specifically for Black students. And that's why we said Black research advanced in intelligence and neurocomputation. And every single one, this is our website that we have, every single one of the mentors are Black. And we deliberately chose them. We actually reached out to the Blacks in Neuro group and looked for people that did research in Blacks in neurocomputation. I contacted these postdocs, graduate students, and asked them, would you be interested in mentoring and working with Black students at UC Santa Barbara? We provide a stipend to them, and the students also get a stipend, by the way, for being in the program. They agreed. All of them agreed, and they're loving the work that they're doing. We have one of the researchers, her focus is on linguistics, again, looking at Ebonics. We have someone that's interested in visual impairment, someone who's interested in different psychopathologies, someone who's interested in physics. So, and then we have Keith who's doing music. He's at the Pasteur Institute. So we have these mentors, or what we call guides, from all over the world, or literally, and they're working with the students. And they're all doing this remotely. And we're just excited to have them. And then the other component of the SEEDS program that's not a part of the brain, we also have mentors, as I mentioned, from different backgrounds and different majors. So why is this important? As a previous speaker just stated, it's really important. Why? Because there's an increased demand for jobs. There's approximately, right now, probably more, 200,000 unfilled positions. There's going to be more than 3 million openings that are expected this year. Employers requested more positions in data science compared to any other skilled job. There's a high demand for professionals with analytical skills. We also need domain expertise, and we need more diverse populations, and thinking is needed to address this underrepresentation. There's a specific need for deep knowledge in diverse epistemologies, ontologies, and axiologies. And we need a transdisciplinary mindset, because what happens is people are just trained in one area, then they can't think about the problems holistically. And that's why, for me, it's really important that we have a transdisciplinary mindset. Having the students work together, they actually acquire that transdisciplinary mindset. So I look at it like this. We're planting seeds at UC Santa Barbara. It's a brand new program. It just started this year. Took us about a year to get it started. And hopefully we'll just increase over time. But again, it's informal, so the students don't feel pressured if they have to get a grade in it or something. And they are working and living together and meeting together consistently, literally every week. So I see it planting seeds, advancing diversity, and I want to thank our sponsors. Google and the Hertz Foundation actually provided us with resources to do this work. And the UC Santa Barbara also have provided us with resources to do the work. And thank you all very much for allowing me to share this information with you today. I am very happy about the SEEDS program and the work that all of you are doing as well. I'm going to pass the mic, as DJ Cassidy says, next to Coach Victor Hicks. He is a K-8 STEAM teacher at St. Thomas More School in Decatur, Georgia. Thank you very much.
All right. Welcome, everybody. My name is Victor Hicks. I do have an adult name when I'm not with my young scholars. I forget. Sometimes it gets easy to forget. But as was mentioned, I am a K-8 STEAM teacher. This is my 7th year teaching computer science here in Atlanta, Georgia, now in private school area. I'm also the owner of Coding with Culture, which is a non-profit organization which focuses on providing genius awakening experiences in computer science centered around HBCU culture and history. So very excited to be among many HBCU family here. I just kind of want to talk about how we're planting some of the seeds beginning with K-8. I think one of the things that I learned upon entering the world of teaching computer science to children in elementary and middle school is that so often the investment in getting kids to want to close the digital divide takes place too late. I think we did some great efforts. I really appreciate a lot of the things that we saw with Hour of Code, which kind of was taken off about the same time as I started teaching computer science in the K 5 spectrum, but realizing that it kind of set our kids up for what I call like the field trip experience. So the kids were very, very excited in December to do all the Minecraft and the Angry Birds but once we put that down in January, I was seeing very little continuity or interest in kids pursuing computer science or continuing to look at those fields as a way to to do many, many things. As we know, it is all throughout. I can't think of a career now that doesn't include some type of computer science or at least computational thought. So I will share my screen real quick. Let me pull this up for you guys. All right. All right. Okay, excuse me. Of course, this is going to be a very elementary friendly thing. So one of the things that we do is in teaching my students, and one of the reasons I was really excited about starting Coding with Culture is because I realized that if we were going to directly address the digital divide, it would be a multifaceted approach. It would not only be presenting students of color, more specifically African-American students with computer science experiences, but also kind of directly addressing and calming a lot of the anxiety, I think, when we talk about entering a field like computer science, because again, the misconception that it is difficult is even with, I think, once we start talking about addressing the racial disparity in the field, we still have a lot of kids who feel like I'm not smart enough, right, across the different areas. And so we want to make sure that what I found or wanted to do, in the program is really provide a wraparound program. So not only giving kids the opportunities to explore computer science, but to give them very clear paths of where people who have similar backgrounds to theirs pursue those fields and where they would be supported. So as a graduate of an HBCU, I said, well, hey, if we're asking kids to kind of delve into the unknown, let's also be as mindful and as of giving them places where they'll be supported in that task. And not saying that, of course, HBCUs are the solution for all, but I remembered how key and it was to me going from the 18-year-old person that came from Chicago to Atlanta. And I thought that, if we're really asking kids to kind of take a chance on something that is the unfamiliar, let's get them excited about doing it in environments that are set up to support them. So one of the ways we kind of do it, I kind of struggle with looking at, what does data science look like for a 5-year-old? So the person that cannot, look into, or as they're struggling to sign into our Chromebooks, into our iPads, how do we get this type of thinking into our kids' heads? And then I really kind of started looking at some of the things we were already doing. And I'm like, we are doing data science, right? I think we're not naming it for our kids, or because they're not dealing with, pivot tables and things like that, we're not really giving them credit for a lot of the thought process. And I realized, similar to programming, we really just want kids to be exposed to the experience and be deliberate about naming some of those things to really build the confidence. And I think that is if there was a key takeaway for the K-8 and definitely the K-5 world of computer science, is really just building that confidence that you're already doing a lot of these things. Your brain can work like a computer, and here's all the different creative ways that you can, you can incorporate that into college and career. So 3 big things we do, focusing on collecting data. That's kind of where we go in through laying down the key skills of, spreadsheets. I think we give kids, we talk a lot about this generation being tech savvy, and they are great at consuming the technology. But we really wanted to be deliberate about laying the foundations to allow them to become producers. So again, a lot of the basic skills of how to use spreadsheets and what does it look like to collect data and organize it in a way that it's meaningful. We definitely have kids analyze the trends. Of course, we more so as the kids grow, that becomes a little bit more complex. I've really loved the K-8 model. Our teachers are very, very flexible as far as incorporating STEAM and computer science into their classrooms. So we've really done some cool observations and having our middle school students come down and work with our elementary school students in assisting them in collecting data. Of course, the older kids, we challenge and push them a little bit more to incorporate those experiences or look for data that is relevant to real life experiences that affect them and their communities. And last but not least, we're really heavy on project-based learning. So the kids are often making decisions from data. When we look at ways that we want to help our community, our 3rd through 5th graders are actually building a pollinator garden here. And we'll talk about the different ways that in Georgia, the soil and all of those things. So again, really, really pushing them to, as they create this data, just getting used to, creating these projects, normalizing, including informed decisions through collecting and then analyzing data and just kind of really getting them, again, laying the foundation with them of what those kind of discussions sound like. Because what I was realizing is that our kids did a great job of rationalizing. And in many cases, we're using data for that rationalization, but we weren't putting enough of a deliberate name on it, if that makes sense. Some of the programs we use, Applied Digital Skills is awesome. There's a lot of pre-built lessons, and you can search by the topic. So if you really want to focus on data collection, it's really project based. So it's not just, you stand there and teaching kids how to format cells. There's always some type of real world tie-in. But of course, with my background being in the fine arts, I had to be a little extra and take the project to the next level. So one of the things things I love to do with my scholars in not only Coding with Culture, which was virtual during the pandemic, it was kind of my teacher brainchild while we were at home. But we're really, really excited to bring it in person into the metro Atlanta area as well. So pretty much how it goes, students are tasked with building their own HBCU. It is a total comprehensive PBL unit from where the kids incorporate online research. They research a famous African-American that they would name the HBCU after. We talk a lot about what makes an HBCU and how do we represent that in a digital model. Or we had, some kids that chose to build out a social media or a digital campaign about this fictitious HBCU that they created. So where data came in as we kind of fleshed this out was we really wanted kids to collect information. Again, just really getting their hands on numbers, right? And realizing that when we research, there's a method, and even just the way that we just formatted. So the picture that we have here, we had some gentlemen from Morehouse. We are all about getting the kids in front of HBCU students. And now we look forward to also getting them back on HBCU campuses as some of the COVID protocols relax a bit. So as they finish, the culmination of their project is they create a Shark Tank type college fair. And pretty much they go and pitch their HBCU to a panel of judges. And a big part of their score, and what I love about the people that come and volunteer, is that a lot of those, as they go through their pitch, is that data. So, for example, we had a group of girls that created, I think it was Kamala Harris University, and they were big about the fine arts. And so our sharks were really heavy on them and saying, okay, well, what data do you have? And the girls chose, we generally kind of break it down into sections so it doesn't become overwhelming, but the girls really had a lot of supportive data and graphs. I mean, things that really blew my mind, the creativity that they took and ran with about HBCUs in the East Coast, and how there was, this number of, women that are interested in taking fine arts, but how there was a disparity of HBCUs that even offered, I think dance was the major. But I mean, some of these numbers, once we kind of let the kids, we gave them those basic 3 pillars, the things they were able to come up with creative wise. And I think sometimes we miss that piece with data because it is so number heavy, is that there is a creative piece. And I've really been, my mind has been blown with some of the things that our kids have done. We kind of give them a little push to go into that world. So last but not least, why do we incorporate HBCUs with the K-8 piece? And I think in kind of coming in, I think everything happens for a reason. I really, really love the fact that I started teaching computer science with really no background. Again, my background was in dance. I was convinced I was going to be a PE teacher leaving Clark Atlanta University, and now here we are. But I think that in looking at that, and really realizing that our kids needed some place to feel successful. And I think as an educator, knowing that seeing how my kids, when they feel supported, when they feel loved, when they know that they are, everyone is really in their corner to be successful, they tend to thrive. Or I would say 99.9% of times, continue to thrive. So I wanted to make sure that as we push children to close this digital divide, that we also give them a clear path to where they can do that and be successful and find mentors and professors who just kind of by default are there for their success. So I think a lot of times we talk about what we want Black and brown children to do. When we talk about computer science and incorporating data science in that, but we also forget to tell them how to get there. And I think that, when we add the unknown, and again, keep going back to that kind of, asking them to do something that maybe never crossed their mind before, I think it proves beneficial for them to be in a place where they are supported. Definitely want to incorporate culturally relevant experiences in computer science. I love the work that has been done lately by the Kapoor Center, and really naming about what that looks like. So again, not just posing the problem and giving our kids the challenge of entering these fields, but also talking about how we must include their culture in a part of that, in the why of the project. So the data might be the specific set or the skill, but then we can get a little creative with what we're asking them to analyze. I think it's also very important to note that we give them examples of experts and trailblazers with similar backgrounds. Coach Hicks, as they like to remind me, I'm old. So of course, I'm only saying all of these things because I'm a teacher and that's what teachers do. But I love organizations like Code House. We're very excited in reaching out to the young women at Spelman. I didn't even realize there was a competitive robotics team. But as cliche as sometimes that seems to sound, I really, really see my kids grow when they have those experiences. So I just love to have my kids talking about HBCUs. And, if we can get some computer science skills in there as a side note, it is definitely welcome. But I think I want our kids, and even in a diverse environment, I want my Black students to realize that even in the midst of majority culture, that their seat at the table is important. And I think it's important for non-African American students to realize that HBCUs are pinnacles of success and culture and all of the great things. And last but not least, I think what I found in just, looking at student data at the classroom level is that data science really addresses a lot of and calms a lot of mathematics anxiety. And I think it's because, where there is a certain level of equation-based knowledge that kids have to have, it really gives kids a creative way to go and kind of get in with numbers. So one of the big things with elementary school math now are number talks, and data kind of speaks to that. So it gives kids a way to get, elbows in with numbers without doing, necessarily the addition, subtraction, traditional class mathematics. So that's just a little bit about what we're doing. We love the fact we'll be sending many, many children to you all. So get ready. We are getting them excited about data science and about HBCUs. And yeah, it has really, really been an awesome experience seeing the young people and what they are able to do with those skills. So thanks.
Well, those were very interesting, and I thoroughly enjoyed listening to everyone. Thank you for what you have been doing in data science and getting our students really involved and intrigued with data science, because we really need it. I must remind everyone who is here that you can put your questions in the live broadcast window, so I can direct the questions to the panelists. If you have one for a direct panelist, make sure you put their names so I can definitely let them know. But while you're doing that, I have some questions for my panelists, because listening to them, I'm really excited about where we're going in the future. And I feel that our students are far better now than we were when we were students. And I only see us moving better and better for African-American students. And I'm glad that Spelman is focusing on our females, because trust me, we are not there. And I love to see how many females are here today. So it says a lot. So I have a question for all panelists. In an ideal world, what would be the next step for your program? Anyone can start. What would be the ideal next step for your program?
So I don't, so because I wear many hats, my explorations as an artist in AI is actually my own, but it makes its way into what I do in my day job at Leicester University. So this past summer, we did an art AI robotics course for high school students. It was dual enrollment. Mm-hmm. So they got both college credit and high school credit in math and art. And they learned how to use artificial intelligence to program robots to make art. Mm-hmm. So we had students from very diverse groups, from India, from Brazil, from Asia, and white students and Black students in the class, girls. And they all did some sort of capstone project to get credit at the end. But the art was important. And then the key part to keep those kids involved and the high school was attempting to use this as a way to attract groups of students who normally don't take computer science and robotics during the school year. And that largely is African-American girls in most cases and some Latino students. And that's who we were aiming to get. And we did get, and no one dropped that summer program, and they all at the end came up with a capstone. So the technology that I was exploring as an artist made its way into the classroom and with Somerville High School teachers at the same time. So in the future, and these kids are ready. There's something that we talked about, the negative impacts of AI. We talked about the Algorithmic Justice League and Joy Buolamwini and her work in terms of talking about bias and implicit bias and racial bias in AI, but they also are learning how to be creative and be creative artistically with AI and robotics as well.
Okay. Dr. Huma, what would you say?
Yeah, so we would like to extend it further down in the academic pipeline, starting from kindergarten. Right now, we have submitted a proposal to NSF to start it at middle school level, where we would utilize their social studies curriculum and math, have 2 classes be in sync, where they can investigate projects like this. And, if possible, also extend it down to elementary school, and of course, make all these topics age appropriate and have them analyze it from that level, so that right from elementary school, they can kind of get used to the idea that everything is data driven in today's world, and they could become familiar with analyzing data, not have the data phobia, as well as be comfortable and realize where math, statistics, computer science, and different domains have that interplay area. And so they can pursue any career. It doesn't have to be a STEM career to utilize STEM knowledge. It can be any career, and STEM can come into the picture there.
Okay. Dr. Oliver, I saw your hand.
Yeah, in working with Jamaica Williamson, our work that we presented today on introducing contemplative practices within the data science program, the results are self-report, right? It's how students felt about the contemplative practices workshops, how they felt about the impact of the research on their interest in data science careers, how they felt about their ability to solve real world problems using, computation. And so for us, the next step is definitely going to be, we have a grant currently under review at NSF, as Tamika was saying, to actually measure those things, right? So getting data from the activities that they complete to see, right, to measure their actual learning gains. And also, I actually want to measure the frequency at which, the students are reporting using contemplative practices in their daily lives, right? But how frequently are they using them? And also, I think it's going to be important for us to follow up with, this is our second cohort that just finished, right? So I think it's going to be important for us to follow up with students that have already finished the program to see if they're more likely to pursue data science degrees or careers.
Vice Chancellor?
Thank you. I think our next steps is more partnerships, placing student and internship programs. We are working on a relationship with the national labs, and also who knows where else it'll take us. and where the students are interested in. Again, our main goal is to give them skills. And I do want to mention that it's quantitative and qualitative skills. So it's not just learning R or Python. We also do topical and sentiment analysis, and they use different software applications to do that. We have to remember that that is core. We have to look at the qualitative aspect of data. We keep forgetting that data is more than numbers. Data is also a story, and we have to figure out ways we can tell those stories. So that's what I would say our next steps are, is partnering and scaling up the program and getting more students in and do some of the evaluations that Tiffany and Tamika are talking about, because we just started to fall and we don't have any data other than asking them how they're doing and having some focus groups, but it's just getting them in and moving on and increasing it.
Coach?
There we go. So for me, I think ideally we would love to do, I would love to see more partnerships from the K-12, from the K-8 spectrum all the way up through college. I think one of the things, again, even just not with computer science, but speaking, about HBCUs, is that we don't, we get kids excited in high school, but the turnaround of that is that they've also spent kindergarten looking at their teachers, Georgia Tech flags and Georgia State. And so by the time they even are introduced to these schools, it's almost kind of like we're playing catch up. So ideally, I would love to get some more programs that focus on kindergarten through 8th grade computer science on those campuses. Definitely more interaction with student bodies of those schools, especially in the areas of computer science or STEM majors, because I think, like I said, our kids are they learn a lot more, it becomes more real for them when they see those people in those fields. So I think for me, if I had to put it into a nutshell, it definitely would just be figuring out what that space would look like in getting kindergarten through 8th grade kids on HBCU campuses. And then kind of diving into computational thought, data science, those PBL units that I think, again, putting them in that physical space has so many benefits for young people of color. So that's my wish list.
All right. Thank you all. Coach, there is a question directly for you from the audience. They say that they're assuming that you use LMS, right, to deliver the content and to collect input from the students. Are there any insights captured in the learning analytics from online and offline? For example, the qualitative research that you would like to share today, pertaining especially to the behavioral trends of these students?
Okay, so as far as the kids that tend to, the kids that are the data that they analyze, or the kids that I work with? The
kids that you work with.
Okay. I would say, our trends have been, as far as the kids who take part in the program, have ranged pretty much. Because like I said, a lot of it has come through my, being an actual classroom teacher. And two of the three schools had pretty diverse, student populations. The Coding with Culture kids, the parents that sign up for the actual, the after school program. We have used a lot more of, because again, that was an all virtual program. So that did depend a lot more on the kids, or I guess depended a lot more on the learning management system. I guess and the second part of that question was there any trends as far as the student participation between the two?
Yes, and their behaviors, yeah.
Okay, so I would definitely say it provided some, of course, the hands-on was a lot more, I think with student engagement, it's a lot easier to see. I will say, though, once we kind of included the HBC, once it kind of became the real world perspective, and I think that's kind of where Coding with Culture was born from, is because we were losing kids on the kind of generic data, presentation. So what would increase that participation and student engagement was the fact that we made it more real world, because, students were excited. We, of course, had the great hooks with the marching bands, and the kids were able to meet, more the Mahogany and Motion girls. So it kind of gave them, once they bought that HBCU piece in, I think, I would say the student engagement definitely, boomed, which is why we kind of kept that culturally relevant model in presenting. And like I said, it carried over into the classroom, but I definitely think we saw a bigger jump virtually with that engagement and student participation. Did I answer the question? Let me make sure I got that.
Yes.
Okay.
You did, but okay. Dr. Uma, the audience would like to say that social justice is a brilliant idea to use, but they would like to know how did you ensure that the use cases cover the fundamentals that are relevant for entry summer jobs?
Okay, so at this in this project, we are involving freshman students. So our goal was not to get them prepared for summer internships in data science. Our goal was to get them interested in STEM. It also includes non-STEM students. And so the initial version, we are having them use a no-code tool to analyze the data, but we do provide resources for them to get familiar with what data science is about, what are the career choices they have in data science, and all the related issues that come in data science, like the bias in algorithms, etc. And so we do have a discussion on that. We provide YouTube video clips, have them watch it and discuss amongst themselves. They get graded on those discussions. And apart from that, the guiding questions that we provide are differentiated. So if a student is really interested and wants to pursue it more, they do have advanced guiding questions that take them beyond just visualizing the data set, but also to incorporate additional data sets to get a better picture, as well as to probably start modeling. Depend on the student's personal interest. But freshman level, at least at the minimum, we want all students to get comfortable visualizing the data in several different ways.
Okay, thank you so much. Dr. Gaskin, there is a question for you, and it has 3 different parts to it. It is asking, you created art using deep learning. So the first question is, how did you introduce students to this technique?
So the AP Computer Science Principles curriculum has several units. And one of the units is around data and information, and another was around artificial intelligence related information. So for data and information, we had music students were composing to data that they had analyzed. And so the high notes would be the higher parts of the bar chart, and the lower notes. And then we also had an opportunity to get the visual arts majors, and these were all high school students, juniors and seniors, to bring them into the space by looking at how people use code and AI to produce tools that allow them to process and create images. And so we explored portraiture, where students were able to pose for each other, then use AI to create, and then talk about how that AI was used, such as deep learning, as I explained in the presentation. And so some of them went in that direction, others went in the music direction. There's even a deep dream related music program called NSYNC, where they can actually use digital fabrication to make a box that finds and invents new notes to compose with. Also came out of Google. So there are lots of really creative AI ways for students to be able to explore.
Okay, great. The next part of the question is, how difficult was it for the students to learn this? And did they need any prerequisite knowledge?
This was the first time the high school had a computer science course in its 20-year history. It was the first time most of the students in the class had taken a computer science course. It was so that this was all new for everybody. And it was also the first time that the College Board had offered that type of class. They found in 9 states for computer science, AP Computer Science A, Black students and girls were not signing up for the exam or for the course. So they created a new one in 2016-17 that would hopefully engage students who normally wouldn't take those classes. So, and that's exactly what I had in class. And so it was definitely an approach that they wanted to take to open up the course, to include more programming languages, to include more applications and connections to the arts. For example, there were theater arts programs doing the course as well, developing curriculum specifically for their students. But it was the arts component, both for the previous one we just did with Somerville High School and the one at the high school for the arts. The art was the component that brought them back and kept them going. And they were learning and more willing to take on challenges. So there's intrinsic motivation because there's something about the work that touches them personally and also relates to their culture or community and keeps them going in the computer science world.
Okay. And the last question to this, they wanted to know what kind of computing power did they need, and did it have any impact on how the course was delivered?
We had laptops. At the time, it was a fairly new lab, so we had newer computers. We also had older computers in a cart that we were able to access, but because we were using online tools, we didn't really need a lot of processing power. Just it does impact how fast things happen, but in general, it was more of just kind of wait to see what the output would be. So anywhere between 2 minutes to 4 minutes or 5 minutes just to get output. So kids were able to really move in, and it was accessible, jump in there and figure it out and actually produce images in a quick fashion.
All right. Thank you. Vice Chancellor, I have 2 questions for you. The first one is, does the Plant and Seed program partner with Black Leadership Academy Experience any at all?
No, it does not. I responded also in chat to that question.
Okay.
But we're open for partnerships. I mean, we're always open for partnerships.
All right. And the next question is, how does your own work on emotions influence the way you structured this program to work with the students' experience?
Well, I would say because of my interest, I should say, in diverse epistemologies, that comes from an emotional space. Because I feel like so often we are marginalized and discounted based on who we are. And a lot of the students of color that come into UC Santa Barbara, it's a Hispanic serving institution. Everybody knows, of course, it's based on numbers. It has nothing to do with ideologies or anything. But many of them that come in don't feel like this is a place that really hears. And I think that's true about most institutions of higher ed, that they're not prepared. They force people to assimilate to a particular way of being. And through that assimilation process, it has an emotional toll on our students, on our faculty, on everyone. And it always informs everything I do. I mean, everything that we do as humans is really, founded on our emotions, on how we respond to things. Any type of learning is based on emotions. If students are feeling stressed, as everyone knows, I mean, it really surprised me. It took them years to figure out mindfulness is important in learning environments. We're not robots. We're not AI. We are human beings. We're organic machines in many ways, but our organic machines, we have parts that need that emotional connection. That's why it's important that we have these types of programs that don't treat us like robots, that treat us like individuals, that treat us like we can contribute, that value where we're coming from. Mm-hmm. And then I think we will see more and more people learning. It really, and I don't want to go on my soapbox, but it bothers me that our students have to come to a place where they're trying to get knowledge so they can move on in life and get a job to take care of their families or take care of themselves, however it might be. And they get stressed, they get burnt out because they don't feel like they should be at these institutions. They don't feel supported and all of that. So emotions are behind every single thing that we do as human beings. And we need to recognize that. We need to recognize that it's important to nurture those emotions, to value them and not force people to think like white men. I think we have to think about how we can value the difference in how we approach life. That's what drives me. That's what drives my emotions. It comes out of my research that I did with teachers and looking at teachers' emotions and whether or not teachers can deal with issues of social justice, How do they deal with it? What's the emotion behind that? So this program comes from years of interest and passion in life, just life. I think we forget that we are living beings, and our lives are grounded in every aspect of our jobs and our homes. And we have to recognize that and start accepting people for who they are.
Thank you so much. Dr. Oliver, I have the last set of questions for you.
Okay.
The first question is, in your research, did you look at the impact of what data science has on other courses that the students did or are doing presently?
Yeah, so that's a great question. One of our follow-up questions that we plan to ask as a part of this NSF grant that we have under review is to see if after they engage in the program, do they take any data science courses? So we haven't looked at it yet, but we do plan to measure it. So that's a great question.
All right. The last question I have for you then is, how did the killing of George Floyd and other subsequent protests impact the students' readiness to learn data science?
I mean, there was a lot of, they were sad. I had students that just kind of fell off because I would take attendance every day, right? And, I had a couple students who just stopped coming. And I, immediately, reached out to them, gave them a call, set up a Zoom meeting, and, they're tears. They're like, Dr. Oliver, this is terrible. I can't, why is this happening? This is on TV. And another thing that happened is there was a Spelmanite and a Morehouse man who, on the news, they captured this and showed it. They were at one of the protests, and they were, not a stun gun, but they were tased.
The tasers.
The police tased them and dragged them out the car, like bust their windows open, dragged them out the car. And so they saw that too, right? And so they were under this stress and pressure from seeing people from their own institution look just like them, their sisters, their brothers, being impacted. And it takes an emotional toll. It's emotional labor, which in my personal experience can be much worse than physical labor.
All right. Ladies and gentlemen, thank you so much for being a part of our panel. We thoroughly enjoyed listening to your work, and I wish you success as you continue to do your research. I look forward to your papers. I look forward to the impact that you will make in data science. And I thank you all for being here today.